First of all, I should introduce myself. My name is Kane Bailing. I'm the Manufacturing Operations Manager for the Wagner Companies. The big thing that I want to start out with, before I let Karen start welding and showing some of the fabrication side of things, is that safety is extremely important. It should not be an afterthought. It should be the first thought, okay? When you're looking at doing metal polishing, I've been in polishing shops that have lit on fire, and metal dust fires are no fun, all right? So you want to make sure that the shop is clean. The reason being is that metal dust is flammable, okay? Metal dust, you start mixing metals together and you can have some really big problems. You mix fine aluminum dust with fine steel dust and it lights on fire, you're not going to be able to put it out. It's got to be smothered to be put out. And that's one of the things in the PowerPoint is I'm talking about a Class D fire extinguisher, okay? I've seen metal fires where, oh, there's a pile of dust burning here and it's picked up with a shovel and put in a steel drum, and they go home for the weekend and they come back on Monday morning and it's still burning. You know, so the idea with a Class D fire extinguisher is Class D, it smothers the fire by when you put it on top of it, it forms a crust over the top of that smoldering metal and it smothers the fire out. You want to have Class D fire extinguishers on hand. We don't have any over here. Right over on the other side there's a big unit, okay? Some of the other problems with metal fires is that if you hit them with a regular Class C fire extinguisher, that it can agitate it. And when you agitate that, the metal dust is actually so hot that it'll burn the fire extinguisher compounds. All right, so very, very important that you're clean. Safety glasses. My poster for how to polish safely. So yeah, safety glasses, earplugs, respirator, gloves, apron, all of the type of polishing appropriate attire. All right, really just no loose fitting garments that you can get wrapped up in a polishing polishing wheel or on one of the air tools. You know, I don't know, anybody who's worn an apron is sooner or later winds an apron up in an air tool and realizes that that's a problem. So we always have long aprons that are secured, tied tight in the back. The other thing is that before you start a polishing job, you should really make sure that you have all of the equipment. One of the worst things that can happen is that you get into the job and you realize that I don't have the buffing compound, or I don't have the stands or this stuff they'll work with, and you trying to make shortcuts or go short on something to hurry up because you didn't have what you needed. You can make yourself and put yourself in a position that you do something dumb. Balancing, instead of having a nice firm stand, you might have a cardboard box underneath it and you can cause yourself problems. So really review up front and make sure you have all of the equipment. I'm going to talk a little bit more about metal dust. If you are going to use ventilation where you're going to suck the metal dust up, make sure that that ventilation is made for handling metal dust. I've seen too many times people get a shop vac and use a shop vac as a dust collector, and the shop vacs work great for small little cleanup things, but they don't work so good when it's a lot of metal dust. Electric motors have a hard time with metal dust. You get enough metal dust in an electric motor is going to fail. Usually metal dust and electricity, you get sparks. When you get sparks in metal dust, you get fires, all right? So a lot of the fires start that way. Other thing with metal dust is that plugs and outlets. When you have outlets, we had two machines, 480 volts, that we had big plugs plugged into the wall, and we didn't hardwire them because we weren't quite sure if those machine locations were going to be there. Metal dust builds up on that, fell into the contacts, and literally blew the plug off the wall because 480 volts arc that way. We hardwire everything that we can. Be very careful about having your electrical outlets. Use electrical outlets that have covers on them. And the last thing I'll say about metal dust is do not use an air hose to clean it up. All right, it's very tempting that you have a big pile of dust and you'll see them going with an air hose and using it as a big power broom. It's a bad idea. You get metal dust up in the air, you have an explosion problem. You have metal dust that's burning and you introduce that much oxygen to it that fast, it can be an explosion and it can get very hot very fast. Big problem. That's my safety speech, okay? Safety is number one. Very, very, very serious stuff. Other thing, cleanliness. Cleanliness of the shop, pretty important, especially when it comes to when you're working with stainless steel and you're working in a shop where you're running a lot of carbon steel, or you are putting a lot of grinding dust into the air. You want to make sure that you're clean because stainless steel rust less, stains less. It still will oxidize, all right, but you can get cross-contamination. I always say, you know, think of your workbench when you're running stainless steel very similar to your kitchen counter. If you're cutting raw chicken on your kitchen counter, you want to make sure you clean it up before you put something else down, because sooner or later somebody's going to get sick. And for anybody who's had a cross-contamination problem, you know how sick you've been from it, because it causes big problems, right? So cleanliness, we pad most of our racks. You can see over here where we're putting a piece of steel underneath, we're putting padding underneath to make sure that we're not going from a steel rack onto a stainless steel pipe. When we're internal, these are just, they are slid in, usually with some tape or some padding. Most of the time that's just to keep it so that it's sitting firm. So cleanliness is important. Other part of it is with polishing belts and polishing equipment. We try to keep same metals with same metals, all right? We don't jump from using these belts on steel and then go on to stainless steel. There's some argument with copper alloys if you can do it or not. As a rule of thumb, the belts are cheap enough, throw them out, use fresh belts on your projects. It's just good practice, good work habits. Planning up front is really, in my opinion, the most important thing. The stuff that I see, and usually when I'm getting the help phone calls from fabricators saying, hey, we're in the middle of a job and it's gone bad, those are the phone calls I get. Usually it is that there was some planning up front that hadn't taken place. An hour of planning up front can save weeks of expediting down the line. It really can. And I'm probably preaching to the choir, but it is really the most important thing I can think of to tell you in all of this is just take your time up front, because when you get to a finishing job, a little bit of pre-planning can save a lot of work on the other end. Okay, what we have is that we have typical two-line rail that we're working on, and what Karen's going to do is Karen is going to talk about and show you how we cope and then weld and then straighten. When we're polishing, or when we're fabricating a railing, things that happen in the fabrication process as it trickles down will affect how well it turns out in polishing. So I'm going to have Karen take over just a little bit for coping and welding, right? Pre-finished materials. Here, when we manufacture, everything we do, we make out of pre-finished material. So this is purchased as number 4 pipe, and from the mills, if you ask for number 4 pipe, you're going to get something that has something between a 60 and 240 grit finish on it. It's very difficult from a mill or most tube suppliers to buy pre-finished material that is an architectural number 4. If you buy it from us, it will be architectural number 4, because that's what we do here. I can do that for you. We use pre-finished materials. It's easier when you have pre-finished materials to see if there's defects in the material, bad weld seams, things that would cause issues in the finishing. When it's been pre-polished, you have it's pre-polished. You can see the cuts and you can see that the material is good. If we're going to use, like, making a number 7 rail, we'll try to polish it all to a number 7 before we fab it. The only caveat to that is that when we run it on our tube laser, number 7 material lasers don't like trying to cut through mirrors, so it's better to have it number 6 or just about to be ready to be buffed out when we cut it on our tube laser. But on this, we're going to start with number 4 material. Now you can go.
The railing that I'm fabricating over there is what he got over there in the polishing area. So it's just the first step before it gets there. So what I'm going to do, if you can see the drawing, I'm going to make a cope all these pieces to be able to fabricate it together, put it together. So that's what we use, the coping machine over there. So what I got over here, I get the depth of the cope, which is always half of the diameter of the pipe. So you can have a good cope part. So I'm going to use that machine over there, I'm going to set it up, and we're going to cope it, and we're going to prep for welding. So it's going to be nosy and really hard. So what I'm going to do, I always put the mark next, of course, in the area that I can see it, and then I'm going to go all the way to the line, and we're going to cope it, and it's going to be a really deep cope so you can hug the other pipe what I'm going to fabricate it to. know it comes out of the coping part of it. So we usually kind of like clean it up a little bit before we actually put it together, because if I go try to put it together right now over here like this, it's going to just interfere the slag into it. So. You like halfway through the pipe, and that's what we usually do.
We'll hang the belts on first. I get phone calls all of the time of, hey, what do you do if you forgot that? There's ways to split a belt and reattach it. There's no secret on how to do that. I'm not going to tell you how I do it, because it's just one of those things that if you hurt yourself while you're doing it, you did it. All right, and I just don't want to go that route. There are companies, all right, that do sell. Walter Abrasive sells a keyway belt that goes together that works okay. I'll tell you that I think that for the money, you're better off just to hang your belts on and remind your fabricator to do that. How many belts do you hang on? I look at when it's an abrasive belt, if you're going to use a 120 grit or a 60 grit, that I use a belt about 1 belt per foot or 1 belt per weld, okay? So when you're looking at, it's an inside loop, there might be 4 welds in there. I'm going to use 4 belts to get those welds out, and I'll hang those 4 belts on. If it's a grinding operation, I'm going to use 4 belts for grinding. So that's a, say those are 60 grit. And then I know that I'm going to use a 120 grit after that, and I'll do the exact same thing with the 120 grit. Will you end up throwing out some belts? Most likely not used, but it's a lot cheaper and a lot faster to do it that way. So we really push for putting those in first. We are using a bolster plate, an old bolster plate as a fab table. Our fab tables, I have very nice fab tables, but they're in the other building and there's some over in the welding area. We didn't want to move our tables, so we put this over here to fabricate. Everything that's fabricated is clamped down hard to the table. This is one of those areas where, as she drags the stainless steel across the steel tabletop, where cross-contamination does take place, all right? These are areas where when you're laying out that you have to think of. You do have to touch this with something, because it has to have good contact to be able to weld on it. We will normally take very good care of making sure that we don't damage the materials in this process. Clamping is another issue where things can get ruined. Every once in a while you'll get the bodybuilder that works for you and really likes to show you how tight he can tighten something, and he crushes your rails for you so that you can see where all the clamps were. It's pretty important to make sure that you have good clamping equipment, and also that people understand that, you know, just because you can turn it that tight doesn't necessarily mean that it's better, you know. I know I'm preaching to the choir, that things start to warp and really start to move around on us. So when we're welding, Karen is getting very good penetration. She's welding, what size wire are you using? 1/16 wire. She's thin filler metal, but we're getting very good penetration. The way that we cope with the belt cope is that belt cope gives us a nice edge that we're able to bring in and blend in. What she's trying to do in the welding side of it is a very good quality weld, saves us some polishing time on that end. That is critical. You know, it's like a bad welder becomes a very good grinder, you know, and a very, that's great, except that when you're pouring a ton of heat into the hand railing and you are really struggling with the welding side of things, you can warp the heck out of the rail, okay? And you will see we have a little bit of warpage in this rail, even though it was clamped down tight, that it's going to have a bow in it. What ends up happening is that you have to go back in and you have to straighten that rail out. When we do time studies, I'm the manufacturing operations guy. Believe me, I know how long everything takes around this place. One of the longest parts of making a hand railing is the straightening process. My better welders have a lot less straightening time. My B quality welders have more straightening time, okay? The other side of that is the more straightening time means that straightening is put a piece of pipe in here and start pulling to get it in, all right? When you put a piece of pipe in and everything's clamped down, you create some problems for yourself because you're using force and friction. That force that's using to straighten that pipe out is also force that's going against the bottom of this pipe against the table that is now cross-contaminating, it's scratching, it's galling, it's doing all of this stuff to the metal that we are now adding time down this path, all right? So in the fabrication side of things, we really do focus on this up front. Like I said, planning first will save you a lot of time down in the end. Planning on this, you save yourself or add 15 minutes to an hour of welding, and you save yourself 5 hours of polishing, your money ahead, all right? So we do spend the time up front. I do a lot of work that it'll be contract work from local people who want us to polish hand railings for them. And they'll come in and they do some interesting fabrication techniques, like tacking their rails to their table so that they can lay it out. Well, that's great, and I'm sure the guy welded it really, really fast, but the amount of finishing time that goes into those jobs offsets any of the time that was saved up front. So think about that. Do you have anything else you want to say about that?
Usually I want to add something to what he said. Usually, though, like he says, the rail will work. So we usually, sometimes if we can, we put a bow on it before we even weld it. Now we lose it, we deep the welding, we loosen it up, and it goes back to 90. So that sometimes can work, sometimes it doesn't work. It depends what kind of railing you are doing, what kind of. So right now it can work like that, but if these boards are a little bit bigger than the size that I need in between this. So when I weld it, weld it in the top, usually this is gonna move this way or it's gonna move the other way. So it helps making a bigger board, and when it goes back to normal, it goes back to straight, and it's a little less straighter, but you're still going to have some kind of straightening to do, so after all.
Is anybody here familiar with backbending and welding?
Yeah.
Preloading, majority of it. We recently, just Karen last weekend had a job where we had a couple setup pieces, and we went through and she actually laid it out and welded the setup pieces, figured out exactly how much it was coming back, and saved me a day and a half on the finishing side. A job that we had quoted to finish on Wednesday was ready to ship Monday morning because of that. It just took all of the straightening time out.
What was the name of that machine?
No, we are just backbending. That's all we're doing. Or preloading.
Usually that's what we do. If it's, like he said, I have a couple extra pieces, I set it up and I see it move a 3/16 of an inch, and then it was already 3/16 off. So I'm like, okay, so if I can move it 3/16 down, and then by the time I weld it, it's going to go up 3/16, I'll be having my 90 a perfect weld, a perfect piece. So that's what, it just comes with either experience or setting up parts and kind of work with them and play a little bit with them.
Seam location. Seam location is a big deal.
Yes.
We really try to run with seams on the inside. That will help. The welded seam tubing, is rolled around and it's welded and on that seam. When you heat that piece of tube up, the seam expands at a different rate than the tube does. So it will always bend so that the banana shape is with the seam on the inside. That's the way it goes. So when you are making a hand railing and you're going to be applying heat somewhere, if you can use that seam location to your advantage, you're better off to think about that. It's the pre-planning stuff in making a hand railing. If you're not thinking about it, the seam locations are everywhere, and you weld it together, and you have this rail that is cattywampus every direction, and you try to figure out what happened, a lot of times you can get all the way back to, oh, it was just seam location. We were not planning that. Heating up metal, even in the polishing operation, you do a really good job in the welding side of it, you have it clamped and everything's fit. When you go over to the polishing area, and we're going to get to that next, is that polishing can apply heat to the metal. Not so much heat, but it's still enough that it will warp a rail. It'll move something with a nice radius on it. You can take that radius and move it all over the place just from the polishing operation. So, something to think about. You good? Okay. So in the welding side of it, this is beautiful. We did a little pre-test with this. We were going to have this clamp down and pull on it. The amount of force that is needed to get this leg back straight again, my table moves. We weren't going to mount it to the floor. So just believe me, it takes a little bit of force to get the leg straightened back out again.
Do you wire welding, or do you do stainless, or do you all TIG welding?
Everything is TIG welding here. Right? We have looked at wire welding aluminum because it's really one of the areas that we think that wire welding would be a fit for us. We do almost no steel. We do no steel for when it comes to welding here. So our stainless steel, our brass, and our copper alloys,
It technically gives you a V in this. So if we put a microscope on here, we could see down to just that finishing line. It's just a whole series of V's like this, all right? When you make a number 6, this is, say, 180 grit. When you make a number 6, all it does is make a smaller V. So now that's a 280 grit or 240 grit, all right? Now, the reason that a number 6 looks duller to the eye, it's not as shiny, it's just kind of more of a matte look. The reason being is that when it's that 180 or 180 grit, that land right there, when the light comes down and bounces back to your eye, it's got a bigger piece of material to reflect light back. When we go to a smaller, like this, less land. Light comes down, bounces back to your eye, you don't see as much, all right? So visually, number 6s look, a lot of times, look less shiny, and it won't be quite as bright. When I have customers come to me and they're trying to match things, what I'm looking at is usually the reflectivity of that. Different abrasives give different lands, all right? A zirconium belt cuts so sharp that those lands are very flat and very clean. So a 240 grit zirconium can actually be as shiny as a 120 grit aluminum oxide just because of the way the abrasive cut. So it's important that when you pick abrasives and how you're cutting that you understand that. There is eye finish, and this is how I do it. I'm not going to argue technique with anybody. I really believe in aluminum oxide belts, and I really, really believe in using the non-woven abrasives. The non-woven abrasives and the aluminum oxide seem to be able to give the true finishes that match most things. There's other ways to do it, and there's other ways to get to where you want to be, but to be able to make sure that your stuff is matching other people's stuff, this seems to work. I had the NAMM finishes manual I was walking around with. That manual is very good. It's generic in some areas, but it's very good as starting places to help you get an idea of what's going on. The Wagner catalog has 2 pages in it of metal finishing stuff. That stuff is really good reference information because, trust me, I'll flip back to that. If you call me up on the phone and I'm talking, I'm making sure I'm not BSing, right? So I open up my catalog and make sure that I'm talking exactly what I'm supposed to be talking, and I will go and really follow those guidelines. And you guys can do that yourselves and look in there. So what Alfredo's going to do is he's just going to show you just quickly a little bit of a technique of how we run the polishing pulley and run a Scotch-Brite or a non-woven abrasive on the pipe. We're just going to show just a little bit just to get an idea and see how he handles it. I'm going to tell you one thing about the tools. And now I'm a manufacturing guy, so this isn't part of the speech, but it just became part of the speech. Because every time I look at one of these tools that they're running these polishing pulleys on, whenever I walk through the shop, I look to see how sharp these are getting. Because when you're polishing, what happens is you're polishing the insides of these, okay? Stainless steel. Cross-contamination, we had a problem one time, a long time ago, with where is this coming from? And we found out it was our flanges that we use on our polishing pulley were steel, all right? And that's where it came from. So these are stainless steel. But what happens is that these start getting sharp. And you guys know that before it gets to a little meat slicer, we take them over to the polishing lathe and grind them flat. One of the tricks, or one of the problems is that a lot of times guys will get lazy and they'll hold on to one arm and use the machine as the weight. If the belt breaks and these are razor sharp, that's where it gets cut, right there. All right. So really pay attention to that. This, we're running on a straight grinder. I like air grinders. I don't like electric tools in the shop. Electric just doesn't work well for me. Metal dust and electricity, you heard my spiel about shop vacs. They just don't last. Can they last? Yes. If you're doing very low volume, it's more than adequate, all right? But when you're doing it hundreds of hours a week, every week, you got to make sure that you have air tools. Air tools last longer. Air tools are a little bit more friendly to work with, I think. They're usually lighter, not as heavy on the guy's arms, and they work, they're workhorses. They run a long time. Buy good air tools. We use, and we'll talk about it, I use Dynabrade. I don't represent Dynabrade. I like Dynabrades. They just last. They're expensive as hell, but they last. You know, Chicago Pneumatic or some of the cheaper stuff that you can get sometimes won't last as long. You know? So he's going to show you how to rope. And we're going to just rope that little bit over there. So working on the polishing and making sure that the tools are the appropriate tools for what you're using is very important. Not just to get a good job or a good end product, but to make sure that your employees are taken care of too. All right, so you probably can't tell any difference. Anybody here a polisher that can tell the difference between these two finishes? No? I can. All right? So what I was talking about in being less reflective, if you look at it, you can see more grain in this leg than you can see in this leg. This leg is actually more reflective. This is less reflective. It's number 6. Okay. I'll tell you one little trick since you're here. If you have problems with finishes and you're having problems with finishes blending in, commercial, you can get it anywhere. Stainless steel cleaner, spray can. When you're done polishing, if it just doesn't look right, and you spray the rail with that stainless steel cleaner, it makes everything even out. And I've saved more jobs that way with cleaning them with that stainless steel cleaner. Why does it work? Usually it basically, to me, it's pledge. Just like what you would wax furniture with. Some of them even smell like pledge. You know, I think they're just putting the same stuff in the can in a different label. What happens is it's a very fine oil. That very fine oil gets down into the grain of the metal, into the grooves that I was talking about. It gets down in there and it makes all of those reflective areas look the same. It kind of blends it in. It's a good way to do it. So that's a trade trick from Kane.
Do you do anything to these welds at all, or is this, or did you polish or
Polish
done
them.
any of those at all, or is that's that from?
He went in with another air tool. Oh, yeah, he's using a wheel like that and going in and taking the color off. Really all on the welds. This was an abrasive, would have been on here. And he was coming in here and coming around and just taking the color out of the weld. And then up in here, getting to the corners with a Dynafile with a bow arm on it to be able to come in and get nice and tight up in here. And this was roped out. So you can see kind of where Alfredo came up here, you can see the transition line where it went from number 6 to number 4. You can see that distinct line. They would have to go in and either hand rub this out, literally hand rub it out to get it to blend in, or come in very tight with the Dynafiles, which you guys are really good at, to get in and around to blend that in. We don't remove, on number 4 and number 6 rails, we do not remove the chevron of the weld unless the customer asks for one piece, all right? Number 7s, it's always filled and then ground out so that it does look like one piece. The skill of the welders helps us a lot. If you have a welder who can really TIG weld nice, no problems, and these will go through the shop a lot easier. Any other questions? Air pressure, our shop line pressure, I believe, is 90 psi. We just run regular shop air. We have big compressors though. So when no, some of the tools we do, we'll put a regulator on them. Okay, so if the thing is spinning too fast, it just blows apart. All right, so I like to have my polishing wheels, these types of wheels, nothing that ever spins more than 10,000 RPM is where I keep it at 10,000. Usually the sweet spot for me is about 7,500. Some guys like things that run a little bit slower, so they'll get down in the 5,000 range, and some guys like things that run a little bit faster, and they'll start riding at 10,000 to 12,000 RPM range. I personally like it slower. I feel as though I have more control. Using them correctly, the shop will be less dirty. Okay? If your shop is horrendously dirty, I can guarantee you I can find out what's going wrong, because most likely you're running too heavy on your air tools or you're running your stuff too fast. Because what's happening is you're actually destroying the buffs, or you're blowing the abrasives apart. You're just stripping all the abrasive off. The metal dust flying around, metal dust is relatively heavy, it lands on the floor. Cotton, on the other hand, doesn't land on the floor. It lands on the tops of the walls and the tops of the vents and the tops of the beams because it gets up in the air, all right? So when you're running polishing equipment, you have to remember that it is the abrasive that is doing the cutting. You have to let the abrasive touch the metal. So if it's running too fast, you put the abrasive on, the first thing that happens, the abrasive blows off. Then you're pushing backing up against metal, and you're trying to cut metal with cotton. It doesn't work so well, all right? So slower speeds is better. Very long answer to that, but very appropriate question. Anything else? Anybody?
Just real quick, so if you're doing, you started with a number 4, your finish is going to be a number 4, you start with the pre-finished material, and you do the TIG welding, you touch that up, you end up roping pretty much, and you got to try to blend that in, and so you pretty much going to end up roping the whole thing again anyway, right?
Right. But we start with pre-finished material because it is considerably easier to take pre-finished material and just clean it up, touch-up finish, than to take mill finish and bring it all the way to a number 4. It's for us, and in mill finish, unless it's the only thing you can get, I would always go with the pre-finished material first. That is, if you want to save yourself some effort. I mean, the quoting, what I do, it's not, oh, it's going to be twice as much. You're talking 20 times as much when you go from mill to and then what you would be pre-finished. So sometimes, every once in a while, you get a jumpy customer that doesn't want to spend a little bit more on their material, and they'll send you their material, and they comes in, and you say, I can't do anything with this because it's going to cost a fortune to polish it. One of the things, the jobs I had a long time ago was actually the shop that Bob Wagner bought out and moved here, H&R Metal Finishing. Boyce Perry taught me everything that he knows. That's the guy. That's how I know how to polish is Boyce Perry. I worked with him for years and years and years. And he's the guy I called whenever I had a question. All right. What Boyce told me is that when people come into your shop and they bring you material, their material, and you quote it, be honest with them and tell them what it really is, because it is very important that you educate these customers. All right. We had a guy come in, had a rail like this or similarly to this, a bronze rail for a church, came in, and we told him how much it was going to be to finish it. And the guy said, that's ridiculous. Ridiculous. It's too much money. I'm going to go do it myself. I can't remember what we quoted him, but say it was $500. It was not much. The guy left. 2 weeks later, he came back with his rail. And we looked at it. All right? And he said, I got it this far. Now how much? I said, probably about $1,500. He said, what do you mean? I've been working on it for 2 straight weeks. I said, yeah, with a Dremel tool. Sell the Dremel tool and stop doing that. And I don't want to have to tell the customers that, hey, it's going to be this much. But I really believe in education. I really believe in talking to the customers and telling them the truth. And what I found out is that when I go to that customer and I quote their job with mill finish material, and I do, no kidding, quote it for 5 times or 10 times more than it would really be, I'm educating the customer. And then they come back to me, and I do it with the material that was a little bit more expensive, and they get a rail that is beyond what they could have ever asked for. One of the things, I go everywhere, and all I see is damage, or I see bad polishing. That's all I see. That's the way my eyes are calibrated. I can't look at a new Harley Davidson without seeing a flaw. God forbid you ever go out and pick out a faucet with me. I'm brutal with it. I polished more Kohler stuff in my life than I care to mention. But all I see is the flaws. When I go out into public and I look around, I know which hand railings were polished by guys out of my shop. And I know which hand railings were polished by guys that weren't in my shop. Because the quality really is different. But that quality is not necessarily so much how strong his arms are. It's how well we planned before we did it. Okay? So I'll get off the soapbox. We're going to talk about this. What? About linear. Linear. We're going to get to that right now. We're going to talk about this next rail. So when I'm hiring somebody, I usually have good understanding that they know how to polish. But I rarely talk technique with them. I rarely talk about what's the best way to do it. Because the truth is that Alfredo and I will polish different. Because what works for me and how I like it to feel is a little bit different than how it feels for him. And I've always given the latitude to my polishers to be able to use their own technique to a point. If they're able to achieve a finish as good or better in the same or less time, why would I restrict how they do it? Every once in a while, I learn something. I'm an old dog, and every once in a while, somebody will come in here and I'll think, why didn't I think of that? So I allow that flexibility. So for when it comes to how warm things are or what's the amount of pressure, I don't know, this is what works for me. And that's where I all the way back at the beginning, where practice is very important.
If you had to identify this as it sits now, how would you identify that number?
7. He's going to clear it up a little bit. He's got a color buff in his hand, and I'm going to go ahead and color buff a little bit. Before you start, so he's using a sisal buff. The sisal buff we use are cotton layers with sisal in between. Okay, it's like burlap bag between t-shirts. Then when he's color buffing, he basically has t-shirt material all stacked up on top of itself. That has been used on brass. But we use it as well. The coloring compound, all sorts of different coloring compounds. That is actually a coloring compound for chrome When stuff gets chrome plated, it comes out of the tanks, it's got chrome burn on it, like a gray black. That's the compound that they use to take that gray black off. It's very, very, very fine. It works very, very, very good for this type of polishing on stainless steel. A lot of chromium and stainless, they play well together. We have a green compound in the book that I like the best, all right? That's the one that I put on sandwiches. That green compound is another color compound. It's just finer than the yellow. Okay? So that works well. The green one works well. The green one's got a little bit more binder in it, a little bit greasier. This one is a lot drier. I'm going to talk just a little bit about number 7 finishes. I'm kind of a purist. When somebody says number 8 to me, I think pure mirror, total mirror. Okay? So when somebody says I want my rail to be a number 8, I can do that. I can make it look like liquid metal, and you're going to pay a lot for it. Okay? So if somebody says, hey, I want a number 8, and I say, are you sure? And they say, yeah. Okay. And I give them a quote, and they say, wow, you're really high. I say, let's talk about finish samples here, because I want you to see what my number 8 looks like, and I want to see what my number 7 looks like. And I show them it, and they go, oh, all I need is this one. And that's a number 7. Because most people realize you put a hand railing in, you polish it to a mirror, and the first time the hand railing is used, it's got a scratch all the way down, you know? And then the cleaning guys come by with their rag and do that, and now it's scratched all the heck. And you just paid for number 8 material that made it through day 1 is number 8, and day 2 it's number 7. So I polish number 7. In my book, a number 7 is that there is a potential that you can see some polishing lines in it or buffing lines in it. All right? Number 8 looks like it's liquid mercury. You should not be able to see any direction at all. When you look at it, you should just see a big nose looking back at you, you know, because it's a perfect mirror. So in our book, number 7. In my experience, and I've done work all over, it's better that way for me to call something a number 7 when it's a number 7, because every once in a while you're going to get somebody to polish that rail all the way to a number 7 first. And then I'm going to rub out those lines, and I'm going to put all the lines in longitudinal, all right? Now, I will start, in this case we didn't do it, because I was trying to kill 2 birds with 1 stone. We used pre-finished number 7 material to fabricate the rail, and when we welded it together, we started with that, and then we're going to rub in the lines. A lot of times, if it's a longitudinal finish, we'll polish all the material longitudinal first, all right? I hate to tell you that there's no real good way to do that, all right? This gantry you're leaning on, I have 2 of them similar to this next door, except they're 26 or 28 feet long, that have swing grinders. There's one probably on a rack over there, that we are setting the material on track and walking down it with a belt and polishing about a 1/4 inch strip, 3/8 strip, turning around, rotating it, and coming back, turning it, coming back, and we end up making it and polishing it longitudinal. Then we'll fabricate the rail. So what we have here is a rail. Alfredo, did you leave the bottom? Wow. Is it milk underneath? So what we have was the way that it was welded. And you guys can kind of lean in a little bit. You can see what the finishing or the polish or the welding looked like to start with. This is the way the welds looked. We're going to come in, we're going to clean those out. In this particular case, because we were doing a longitudinal finish and we were still going to leave the weld chevron in there, we did not put extra filler metal in to polish it out to make a perfect number 7. When we flip it over, you're going to see that it's going to look a little bit undercut when we go to that number 7. The reason it's undercut is because we were making it for longitudinal and then changed gears in the middle. So we would add a little bit more filler metal so you wouldn't see that in the number 7. In the number 4 longitudinal, you would still see that there's weld seams in there. Important to make sure the customer understands that, but for us, the standard is just leave the weld, not draw. So, polish into a number 7. Boyce Perry used to tell me all the time, Kane, more compound, push harder. You know, he's also the guy who told me that good polishers are only qualifications is a strong back and a weak mind, and he always told me I was overqualified. So, in this, I'm going to talk a little bit about polishing to a number 7. When you're polishing material, if you can buy material number 7, great. A lot of times you can't, all right? Depending on what you're doing, if it's tubing, if you're making a rail out of tube, tubing is a little bit more friendly to polish and pipe, okay? For some reason, pipe, when it comes in mill finish, has always got grayscale on it, stainless steel. That stuff is usually hard as nails to get off, and you gotta grind through it. So a lot of times when it comes to tubing, or in pipe, if I could buy it and I bring it in pre-finished, I will take pre-finished material and polish it up. So technically, I'm thinking the number 4 just did all the rough cut for me. All right, so I don't have to take that grayscale off. If I'm polishing tubing I can bring in mill finish, and for number 7, it's a little bit easier to work with. So I'll take mill finish tube and polish it up to a number 7 while it's in its straight. Okay. When it's straight finishing, same thing. We do all the belting operations. I have a very big automatic next door that I'll do all the polishing circumferential all the way up to where it can be buffed, and then we buff it linear. Okay. As we're going through it, we're paying close attention to how warm we're getting the tube. When you have tube polishers, if anybody here has a tube polisher, I'm sure you know that you start getting the pipe warm and it starts coming out on angles and up and down, or if it's spinning, it starts whipping really bad. All of that is a product of heat, and the trick is to try to keep it cool. The way to keep things cool when you're polishing on them, not too much pressure. More passes, less pressure. You know, if you try to get it all done in one pass, I guarantee you're gonna ruin your abrasives, you're gonna ruin your machine, and you're gonna ruin the material. The long way is the better way. More passes, less pressure. If you can keep it cool and you keep it straight, a lot more friendly to work with, easier in the end. So we bring it all the way up to a number 7. We got it to where we can fabricate it. We do all of the same things we do on everything else. We put it together the same way. Just now the touch-up is a little bit different. Okay. So when we're going in on this, we're going to go in, and Alfredo grinding the welds here. I grind welds off. Everybody has different techniques. Some guys like to use little disc grinders. Some guys like to use the Dynafile arm. I like using big disc grinders. It's just what I learned how to use. So I will use a big disc grinder to actually blend that in. What I like about going over things when I'm doing a corner like this with a big disc grinder, and you can see the difference when we get on the other side, is that when I'm grinding across this, I'm able to touch the weld only, and then as the weld comes down, I can be touching on the elbow and on the pipe side. And I can tell when I'm getting it flat. If I'm just going in this one spot here, the guy with the Dynafile, or with the Dremel tool, he can't tell how low he's getting, and the next thing you know, he's got it scooped out. All right. Some of my guys are really, really good with Dynafiles, and they're able to just take this down and they're able to blend it in and get it nice and flat. That's not my case. I know Mike and Nia are good at it, and Alfredo is also. But I like to polish the wide area first and bring it all the way around. And then I know it's nice and straight. Let's flip it back over here. So where you can see the dip, a little bit of a dip in this one, that we will be chasing to get that high spot out. And that's the problem. When you are looking at a railing, one of the biggest issues in polishing is that a low spot will look like a dent. When you look at this, when you look at a rail, the lights above, you see a line on the pipe. And when your eye makes that line of light travel down it, any distortion, that line jumps. And you can see that there's a dip. And you can feel it with your hands and be like, there is no dip in there at all, you know, and your customer is going, I see it, you know, and you got to work it out. So in the polishing side of things, why I like to use a bigger grinder is that you don't run the risk of getting that dip in there. We would be working to get that dip out, right? Keep this from being all day event. We went after this a little bit faster this morning, and there is a bit of a dip there. But I wanted to focus more for this demonstration, not so much on grinding the welds, because everybody can learn how to grind welds. I was going to learn a little bit about how to buff, all right? So what Alfredo did is he got this smooth enough to a buffing surface. So what is this? What grade? Are we at 400? 400. All right, so when we polishing finer and finer lines, what we did is that we ground the weld out, most likely started with a 60 zirconium. As soon as we had it fine enough or low enough that we weren't all the way down, we went back over it, probably with a 120 aluminum oxide to cut the zirconium lines out, then back over it again, over here. Then back over it again to take out the 120, the 240, the 240 with the 320, the 320 out with the 400. Once we get to the 400, it's able to be buffed, all right? For our purposes, we're going to be using Boyce Perry's favorite compound is yellow one. He used that on everything, even sandwiches. It's a cut color compound. The steel compound. It's we have it in our catalog, and it's the compound that we like to use the most on stainless steel. What it does is that it cuts. It's not really greasy, so it doesn't really get all over everything. But it's greasy enough that it stays on the buffs well. But when you buff, it doesn't put really harsh lines in. You know, polishing compounds, all different grades. This, I don't know what the grit would really be in here. I'm guessing it's got to be somewhere in the 1,000 grit, something like that. That's mixed with a binder. There can be emery cake that could have 120 grit in it, and it's buffing compound, and guys go to buff with it, and it's got scratches, and you can't get them out. It's important that you use quality stuff and you know what you're using. All right. In the NAM manual, it talks about making a number 6 finish, and it talks about using a Tampico wheel. Somewhere, sometime back before I was born, and probably back before most of us were born, that's how they did number 6s, was Tampico wheels. I have a Tampico wheel. I keep it because it's going to end up in a museum someday. In the purpose for what we do, Tampico wheels is gone, emery cake is gone. Higher quality buffing compounds and sisal buffs are what we're using now, you know, and abrasives, non-woven abrasives. So, Alfredo, if you want to just buff a little bit for these guys, show how you go after that. Everybody paid close attention to what was happening there, right? See how much compound you put on that buff? You see that there's not compound all over the floor in a big liquid puddle? All right. Anybody who's been in a polishing shop long enough with enough rookie polishers knows that a polisher really likes to use that compound bar on that buff, right? And you push it on there until it starts melting and running down your hand. No. Compound, you put compound on a buff, you put it on, very thin layer goes on the buff, you buff a little bit, you add more compound, you buff a little bit more, you add more compound. If the compound is dripping, running, melting, flying, smoking, any of that, you're doing it wrong. Period. You're doing it wrong. Compound is put on and just put on. Compound is what cuts. Another thing, if you were paying really close attention, you saw him working and you didn't see him leaning with all of his might on that. All right? He was letting the wheel do the work. He wasn't using his arms. Okay? The buff itself is the medium that pushes the compound onto the pipe that allows the compound to do the cutting. If you are pushing too hard, you are not allowing the compound to do the cutting. If you push too hard, all you're doing is stripping the compound off the buff, and you're trying to buff apart without using any compound. It's very important that you remember that in polishing. Another thing that is difficult when it comes to metal finishing and polishing is that pipes, stainless steel isn't as bad, aluminum is worse, copper is really bad. When you're fabricating something and the metal itself is actually cold, it's cool in the shop or it's cold to the touch, when you take that compound and you put it on the buff, what causes the compound to stick to the buff is the heat from the friction, okay? So you have now warmed up the head of the buff, you've warmed up the bar of compound, and it's now stuck onto the buff. You take that nice waxy material and you put it onto a very cold piece of pipe, and the first thing that happens is all the wax transfers from the buff onto the pipe and builds up a little layer, and it sticks right to it. Okay? So, depending on how it is, most of our stuff is not as we don't have this problem that much because we're usually working on stuff and staying warm. It's not super cold in our shop. But if you have problems where compound is pulling off, warm the pipe up. All right? You don't have to get it to where it's smoking hot. You should be even able to hold on to it. all right? But warm to the touch will help. It'll help in buffing for sure, but it also helps in other polishing, all right? A little bit warmer material allows everything to work better. It allows the greases that we use for polishing, it allows that to flow a little better. It works better. So warm is good, hot is bad. In any of the finishing demos I've ever done is if I say, if you see smoke, stop, something's wrong, all right? If you see it or smell it, something's wrong. Coloring compound, all sorts of different coloring compounds. That is actually a coloring compound for chrome. When stuff gets chrome plated, it comes out of the tanks, it's got chrome burn on it, like a gray black. That's the compound that they use to take that gray black off. It's very, very, very fine. It works very, very, very good for this type of polishing on stainless steel. A lot of chromium and stainless, they play well together, this compound is stainless steel. Manufacturers, find your manufacturer that you like and buy it from them.
Is that not in your book?
That is not. That is not. We have a green compound in the book that I like the best, all right? That's the one that I put on sandwiches. That green compound is another color compound. It's just finer than the yellow. Okay? So that works well. The green one works well. The green one's got a little bit more binder in it, a little bit greasier. This one is a lot drier. I'm going to talk just a little bit about number 7 finishes. I'm kind of a purist. When somebody says number 8 to me, I think pure mirror, total mirror. Okay? So when somebody says I want my rail to be a number 8, I can do that. I can make it look like liquid metal, and you're going to pay a lot for it, okay? So if somebody says, hey, I want a number 8, and I say, are you sure? And they say, yeah, okay. And I give them a quote, and they say, wow, you're really high. I say, let's talk about finish samples here, because I want you to see what my number 8 looks like, and I want to see what my number 7 looks like. And I show them it, and they go, oh, all I need is this one, and that's the number 7. Because most people realize you put a hand railing in, you polish it to a mirror, and the first time the hand railing is used, it's got to scratch all the way down, And then the cleaning guys come by with their rag and do that, and now it's scratched all the heck. And you just paid for number 8 material that made it through day 1 as number 8, and day 2 is number 7. So I polish number 7. In my book, a number 7 is that there is a potential that you can see some polishing lines in it or buffing lines in it, all right? Number 8 looks like it's liquid mercury. You should not be able to see any direction at all. When you look at it, you should just see a big nose looking back at it, because it's a perfect mirror. So in our book, number 7. In my experience, and I've done work all over, it's better that way for me to call something a number 7 when it's a number 7, because every once in a while you're going to get somebody that's going to come back to you and say, hey, this isn't the number 8. And you're going to say, oh, okay, and then you have to fight that fight. And that can be a real pain, especially if it's 1,000 feet of rail, all right? A lot drier compound. So, color buffing. All the color buffing did is took out the grit finish from this. Kind of say that's 1,000 grit. And this is 2,000 grit. It just took those little bit of lines out. All right. That buff or that air tool is running a lot faster. That's probably pushing that 10 to 12,000 RPM range. That for color buffing, that works pretty good. It keeps everything dry. It keeps everything moving. It also keeps things a little bit warmer, so it keeps the head of the buff a little bit warmer. For the color buffing side of things, that works well for him. If I was doing it, it would be the exact opposite. Mine would be going at the bottom end. Because I like for color buffing really slow. For me, that works better, okay? I'm probably as clear as mud here. What I'm saying is that when you go through and you're using the right equipment and the right tools, it comes more than it to feel, all right? He's not pushing at all. The material is moving fast. When I'm going, I have a little bit more technique where I'm using a little bit more weight on the buff, but mine's running slower, all right? So I'm a little bit heavier on it. Where it comes down to is that, and I'll tell you this for your own shop, is that when you're polishing, you should get a good idea about how much you can produce an hour, and then work your structures off of that. And I can tell you, and I'm not going to talk any dollars or anything here, but when people practice and do this, I've done polishing work in China. I've been over to China and watched guys polish. It is basically the same as what we're doing here. So if I went from his shop to your shop to their shop, and you got guys who are practicing, and it's all about the same time. So it comes down to what your costing structure is and how you build that, okay?
No.
So it depends. It could very well be the material. Some of the lower end, and right away I go to the material because I love beating up our purchasing guys. Lower end material, you know, there's alloys in there. And if that alloy is a little bit funky and you have a little bit more nickel and not as much chrome, or it's not as consistent, you can get some color shifts in the polished rails. We've had it stainless steel that's running, even though it's all 304, some of it's running a little bit more high on the nickel content than on the chromium content. You'll get a rail that's polished number 4, and you'll have one leg of it, and it's like, does that look yellow to you? You know, and everybody's standing there looking at it. And it just happens that one of the sticks of material had more nickel in it. And that can be sometimes when you're buffing where the issue comes in, is that it's the material. The next thing, so you call me up and you say, oh, I got a problem, I have a spot on my rail that's not polishing well. I would say go back over it and polish it again, but make sure you're using enough lubrication, all right? When you're using an abrasive belt, you want the belt to cut the metal, not tear the metal. Anybody who's cut aluminum on a chop saw, run it dry. Run it dry 3 times. And it's so galled up with metal that it's now no longer a silver cut going through. It's a big gray kind of greasy mess going through. That's from no lubrication, and it's now tearing the metal, kind of melting its way through and ripping it. And it galls up, all right? Abrasive belts are exactly the same. You put a little bit of lubrication on that blade going through that aluminum, and it'll cut nice and shiny silver all the way through it, And the carbide teeth never load up. The lubrication kept it cut and clean. With the abrasives, what happens is that when you cut, and aluminum's the best one to see it, is that it starts to scorch. What is that scorch? It's not cutting the metal, it's tearing the metal. When the metal tears, it's a lot less even. And when it tears, it's hard to buff it out. So if you took that 400 grit that Alfredo's working on here on a piece of aluminum and ran it dry and got it perfect and everything is dry and it's as smooth as it's ever going to be and try to buff it out, you won't be able to get it shiny no matter what, all right? But you go back over it again and you grease up a 400 grit belt and you go over it and you grease it all out. Then you go and buff it. It buffs smooth and clean as butter. Why? Because the metal was cut instead of torn. In the handout, I'm sure you'll see me refer to polishing. There's 2 things. There's polishing and there's buffing. So if somebody calls me up and says, can you buff my rail? That is buffing, and buffing only, all right? Can you polish my rail? Yeah, I can polish your rail, but it's polishing only. Can you give me a number 7 material? Oh, I polish and buff. Can you? So I really am picky with that. But when I am going to take a rail and I'm going to polish it, I go polishing, and it's going to be ready for buffing. You have roughing, dry fine, oil. Roughing is the zirconium belts or the aggressive belts, the 80s, the 60s, the high-end aggressive to remove metal. Dry fine is the stuff to take out all of that rough stuff, all right? Dry fine, the nice thing we call it dry fine is that you're drier, fine. Drier belt, fine. A little bit of lubrication on it, but you can really see that it's a fine belt. You can see that you've taken out all of the imperfections. You've taken out all of the 60 grit lines or 20 grit lines, and when it's dry fine, it should look nice and flat and even. The last operation before buffing, the reason I call it oiling, or the camp I grew up in called it oiling, is because we were literally oiling the parts. The belts were soaked in fuel oil, diesel fuel, and we would go over with grease and diesel fuel and go over them, make them that smooth. They'd be greasy and grimy as can be, and then it's like that, then buff it out. And that's where you buff it out. And that will get rid of that mark. That's usually where the next.
So it's not the buffing of it, it's because something was done
Before.
before.
Yeah. And I wanted to set a theme for this, and we're almost done with the whole talk. The theme that I wanted to set is that it is all cause and effect, all right? In metal finishing, if before this first piece of metal was even ordered from the mill, if the plan is in place that you know you're going to make a number 7 rail at the end, think about what material you want to start with it. And sure as heck don't call the guy up and ask what the cheapest material he has for that is, because most likely he's not going to save you any money. Really think about it, because every step down the way will guarantee what this looks like in the end. All right? Now, Steve said it in his presentation. The number one reason for rejects that I know of in hand railing business is because what it looks like. Boy, it could be core drilled holes, and that thing falls in there dead center in those holes. Grouts in perfectly fine, level, all the rise and runs are perfect. And the guy walks in and says, "What the heck is this?" You know, and it's because it wasn't polished correct. And if you were going through and you put as much detail in making sure that all the dimensions were right, as making sure that your finishing was going to be right, there's a higher success rate. I am passionate about that, because I can't tell you how many times and how many now and over the years, thousands of phone calls I've gotten to help. You know, I have a customer rejecting this thing for finish. Can I put you on a plane and fly you out here? You know, I would love to. I can't, you know, but we work through those issues. Anybody have any other questions?
Yeah, 304 and 316 stainless.
Polishing wise, I don't notice any difference in it. It's a little bit harder, okay? 316 to me is a little bit harder. There's more chromium in it, so it cuts a little bit different, but in the overall, no.
What types of tools do you use for like tight spaces, like a thicker rail?
Okay, so we will use, depending what somebody's looking for, pre-finished material Alga puts together, and we got to get all the burn out of the picket railing. We will use a weld burn remover. I think we have one from Walter now. We will use that. What it does is it allows us to be able to get in there and get the black or blue out, and then a lot of it is this finger. It's in there like this. And then it depends on what it is. A lot of Dynaphiles. Dynabraid, if there's somebody here that represents a different air tool company, I apologize. I've had good luck with Dynabraid over the years. Dynabraid has got a really nice catalog of parts that work well for the metal finishing industry. They have a lot. Walter, it's a Surfox. The Surfox. It's not a grinder. No, it's chemical. They work nice. I resisted it. The one problem that I had with the Surfox is that people had the notion that if you used it, and we should have set it out, is that it'll remove the burn, all right? But it won't remove the burn and leave it polished. You still have to buff this out. All right? Just takes color away. Takes the oxidation off. So in picket rails, you would want to have everything pre-finished. So when you put it together, everything was nice. All those tight corners are all polished. You go in there and you weld stuff in. Usually picket rails are welded underneath, not on the top corners, and clean it up. If they're welded across the top, that's usually steel is where I see that. Then we would go in with a Dynaphile and actually just cut down and take out any of the BBs or any of the stuff that's up on top. A lot of anti-spatter spray. This is the oil for, when I said oil, and on the fine grit belts. So we use grease. Formax F122 is the white grease that I use on everything. That just keeps my hands nice and soft in the winter too. That grease we use on everything. This is the finer grease. A lot of the greases are so heavy that when you get to 400 grit, it loads the belt up so much with grease that it won't cut anymore, all right? Sometimes I get guys that think, oh, I got this new WD-40, Croil, whatever they use, and they spray it on, and then they try to use their abrasive. Well, the lubricant is so lubricating that the abrasive doesn't cut anymore. They sell sprays that are more suited for those fine abrasives. That's what this one is. So it really is just a very fine oil. And this is what we use. In small shops, mom and pop shop, Weiss's shop, we use diesel fuel or fuel oil. I had a 55-gallon drum of fuel oil, and everything got wiped down in fuel oil. Here, my safety committee would throw me out the door. So we buy this. And it's excellent, this is called polishing metal. It works very well on the fine stuff, and if you're doing anything in aluminum. It's beautiful on aluminum. Don't be afraid. There's no dumb ones. No dumb questions at all. Have I covered enough, Steve? Oh, all right. Tony pointed out to me, I'm very short-minded, so I only read the NAM part. It's NOMMA, all right, too, on there. You guys should all have one of these. It should be very close to your hand when you're quoting. It should be something that you understand. There's great information in here. All right. I did have a little bit of input in writing it. There's some things in here that are a little different than I would do it, but it is a great starting point. I'm going to go one more time on a soapbox. Metal finishing, back World War II, the U.S. equivalents, all right? Right at the end of World War II, all of the standards for metal finishing kind of died, all right? Builders Hardware Manufacturers Association, BEMA kept them going, all right? BEMA has a book of standards out there of what hardware should be finished to. Hardware is hinges, doorknobs, and all of that. When I set things up, polish to try to match the Builders Hardware Manufacturers Association standards. The stuff that is in the Wagner catalog, the end result, if you do that, will match specific BEMA stuff. In this book, there's all the cross references from BEMA to ANSI to all the way across. So if you follow most of the directions in these books, you will get an end finish that is the same in Rob's shop, over in your shop, and they'll match, okay? I have been more times than not called and be, hey, I need to be the expert in metal finishing. What is a number 4? Anybody? 120, all right. There's no such thing as a number 4 finish. There's no legal grounds to stand on in a number 4 finish. It is in the eye of the beholder, okay? The industry standard on a number 4 finish is the BEMA standard gets to about a 120 grit. A 120 grit on a stainless steel was softened with and then this, you know, and if you do that same thing on aluminum, not so much. So when you are going to quote jobs or you're talking polishing, really direct your customers and yourself to follow something. This is a good tool. I use this tool. I have this tool. I have an old version of it when it was all in single pamphlets. I read this. The Wagner book, I said it early on, I keep that very close to myself when I'm on the phone so that I am looking down at this is what I am doing so that I'm always giving consistent direction. Because when it comes back, finishing can be a trick, all right? And when it comes back to you and somebody says, hey, I didn't get what you said I was going to get, I don't want to be in that argument. I can say, did you follow what they said in this book? And it saves me a lot of effort.
Where do you get that book?
You can get it from the NOMMA bookstore.
NOMMA,
and yeah.
Go online, buy it from NOMMA.
It is well worth whatever it costs. It's well worth whatever it is. And there's tons of, this is all the metal finishes. So the copper alloys are in here, all the different finishes, all the cross-referencing stuff. This is the Bible of metal finishing for me. It really is the Bible of metal finishing for me. It's one of the few places that's all put together. Even though that BEMA did a great job with keeping the standards going, they didn't ever collected anything this comprehensive when it came to finishing. So this is a great tool. Anything else? Oh.
We did the railing, stainless railing, and it's staining just up the railing in front of your shop.
Tea staining?
Is that from the salt?
Salt. Yep. Stainless steel. There's certain things, obviously you can do stuff to that. I'm a metal finisher, so let it stain. I can polish it for you, all right? But really is that going over it with we pushed a little bit on a citrus-based passivation process. Those take the free carbon out and it slows that down even more. It will, the free iron, it takes it off of it and it'll slow that staining process down. One of the problems you have though is that you're picking up exhaust and crap that's floating around in the air, and that's not even, that orange isn't even emanating from that pipe. It's from something it picked up in the air. I don't remember who I did it for, but years back, I live in Waukesha, and at the time I lived near a manufacturing company that the exhaust from their company was landing on our grass, and when it rained outside, my grass would rust. Well, I have defective grass. Somebody sold me bad grass. Stuff is rusting, right? It has nothing to do with the grass, and that would be an argument because, hey, why is my railing rusting? The railing isn't doing anything. It's picking up crap out of the air. So keeping those things clean, following the cleaning instructions.
Also, you mentioned number 7 performs better than a number 4.
Yeah. I talked about those V's when you polish and you cut those grains in like that. When you get a number 4 finish and one of them little particulates lands that came from somebody down the street and lands on there, it sits in that nice little groove and a drip of water gets in there and then the thing bleeds and you'll see it go right around the tube, all right? So if I'm ever in an environment, number 7, where I want something to really last, 304 polished to a number 7, rarely would you see any staining on it.
How about 316?
316 is even better, all right? Sending things out to get passivated, if it's going near a pool, Midwest, any road salt stuff is a nightmare. Pools are bad, chlorine is horrible, ammonia is bad, that kind of stuff. Anything else?
I'm done. I'm out of things to talk about.